projects. In this video, we are going to explain about the project, which is detection of ransomware attacks using processor and disk usage data. Introduction of the project. The project addresses the growing threat of ransomware, which is a form of malware that encrypts files or logs computers to extort money from victims. It highlights the increasing frequency of attacks, with 70% of business falling victim to ransomware in 2022. The project emphasizes the alarming trajectory of ransomware attacks, predicting that by 2031, a business, consumer, or device will be targeted every 2 seconds compared to every 11 seconds in 2021. The estimated damage cost is expected to exceed $265 billion by 2031, showcasing the urgent need for effective detection methods. Traditional signature-based detection methods are vulnerable to polymorphic and metamorphic ransomware variants. The project underscores the limitations of such approaches and advocates for behavioral or runtime detection that observes the dynamic actions of ransomware during execution. Implementing runtime detection on the target machine involves continuous monitoring, data collection, and analysis of various processes. The project acknowledges the resource-intensive nature of this approach, highlighting the potential challenges posed by ransomware attempting to evade detection through camouflage and process manipulation. The project proposes a novel method utilizing hardware performance counters to detect ransomware in real time, which are HPCs. HPCs are special purpose registers that count processor and system events, offering a more efficient and less intrusive means of monitoring. Machine learning models are employed to analyze HPC and disk I/O data collected at the host machine level, demonstrating high accuracy and speed in detecting ransomware execution, particularly virtual machine and cloud environment. Objective of the project. The primary objective of the project is to improve the accuracy of ransomware detection methods by employing advanced techniques such as VMware, hardware performance counters, which are HPC, and I/O events data. The goal is to achieve a detection high accuracy, surpassing the limitations of traditional antivirus solutions. Addressing the drawbacks of existing detection methods, the project aims to minimize the impact on system performance. By utilizing virtualization technology and extracting features from HPC and I/O events data, the objective is to create a detection mechanism that operates effectively in real time without adversely affecting the overall system functionality. The project seeks to comprehensively evaluate the performance of various machine learning algorithms, including SVM, KNN, decision tree, random forest, and XGBoost. Through extensive experimentation, the aim is to identify the most effective algorithm for predicting ransomware activities based on extracted features. In addition to traditional machine learning approaches, the project explores the capabilities of deep learning models, specifically DNN and LSTM. By investigating the potential of these advanced techniques, the objective is to determine whether deep learning can offer the superior ransomware detection capabilities compared to traditional algorithms. The project aims to contribute to the cybersecurity community by providing a publicly accessible dataset. This dataset, generated from diverse programs like 7-Zip and AES, enables other researchers and practitioners to validate and benchmark their own ransomware detection models. The sharing of such data promotes collaborative efforts in developing robust solutions to encounter the evolving threat landscape of ransomware attacks. To implement this project, we need software and hardware requirements. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. In this step, the necessary Python libraries and packages are imported. We have imported NumPy for numerical operations, Pandas for data manipulation, Matplotlib and Seaborn for data visualization, and frameworks like TensorFlow for deep learning, Scikit-learn for machine learning. The next step is data exploration. Here, this module involves exploring the HPC I/O events dataset to gain insights into its structures, features, and distribution. Data exploration helps in understanding the characteristics of the dataset and identifying potential patterns or anomalies that influence model training. The next step is visualization. Data visualization techniques such as histograms, scatter plots, and correlation matrices are employed to visually represent relationships between different features. Visualization aids in identifying patterns, outliers, and understanding the distribution of the data, which is crucial for effective model development. Data pre-processing. This module involves preparing the dataset for model training. Common pre-processing steps include handling missing values, encoding categorical variables, and scaling or normalizing numerical features. Pre-processing ensures that the dataset is in suitable format for input to the machine learning model. Here we have sub-steps. Shuffling. Shuffling the dataset is essential to randomize the order of the data instances. This step helps in preventing any unintentional patterns that might emerge during training due to the original order of the data. Normalization. Normalization is applied to scale the numerical features of the dataset to a standard range. This ensures that all features contribute equally to the model training process, preventing dominance by features with larger magnitudes. Splitting the data into train and test. The dataset is divided into two sets, a training set used to train machine learning model and testing set used to evaluate model's performance on unseen data. Building the model. This involves identifying the architecture of the machine learning model. Algorithms are specified in this step. The next step is training the model. The model is trained using the training dataset. During training, the model learns the patterns and relationships within the data, adjusting its parameters to minimize the difference between predicted and actual outcomes. Flask framework with SQLite for sign-up and sign-in. Flask, a web framework, is employed to create a user interface. SQLite, a lightweight database, is used for user registration, which is sign-up, and authentication, which is sign-in. This provides a secure environment for users to interact with the model. User gives input. User provides input through the Flask-based interface. This input is then pre-processed to ensure compatibility with the model's requirements. The next step is given input is pre-processed. The user-provided input is pre-processed to align with the pre-processing applied to the training dataset. This step ensures consistency and compatibility between the input data and model's expectations. Trained model is used for predicting the result. The pre-processed user input is fed into the trained machine learning model. The model applies the learned patterns to predict the outcome based on provided input. Final outcome is displayed. The predicted result is displayed to the user. This outcome provides information on whether the input is indicative of a normal or ransomware script execution, offering valuable insights for cybersecurity purpose. Algorithms which are used in this project are long short-term memory. It is a type of recurrent neural network architecture designed to address the vanishing gradient problem in traditional RNNs. It utilizes specialized memory cells, input, get, and output gates to efficiently capture and retain long-term dependencies in sequential data. LSTMs excel in processing and predicting patterns in time series and sequential data due to their ability to selectively update and forget information over extended time periods. It is employed to analyze patterns and dependencies within the HPC and IO events data, providing a deep learning perspective of ransomware prediction. The next algorithm is deep neural network. It is an artificial neural network with multiple layers comprising an input layer, one or more hidden layers, and an output layer. They are capable of learning complex hierarchical representations of the data through the use of nonlinear activation functions and backpropagation algorithms. They are particularly effective in capturing intricate features and patterns in large datasets, making them suitable for a wide range of machine learning tasks. DNNs are applied to extract intricate features from the HPC and IO events data, enhancing the model's ability to discern between normal and ransomware script execution. XGBoost, which is extreme gradient boosting. It is an ensemble learning algorithm that combines the output of multiple weak learners, typically decision trees, to create a robust and accurate predictive model. It employs a gradient boosting framework, sequentially adding trees to correct errors made by the previous ones. XGBoost is known for its speed, scalability, and ability to handle complex relationships in the data, making it a popular choice for classification and regression. It is chosen for its ability to handle complex relationships in the data and provide accurate predictions. The next algorithm is random forest. It is an ensemble learning technique that constructs a multitude of decision trees during training and outputs the mode of classes, which are classification, or the average prediction, which is regression of the individual trees. Each tree is constructed using a random subset of the features and contributes to the final prediction. Random forest mitigates overfitting, increases model robustness, and provides a more accurate and stable prediction compared to individual decision trees. It is utilized to mitigate overfitting and enhance the stability of the ransomware prediction model by aggregating predictions from multiple decision trees. The next algorithm is decision tree. It is a tree-like model where each internal node represents a decision based on values of specific features. Each leaf node represents the outcome or class label. Decision trees are used for both classification and regression tasks. They recursively split the dataset into subsets based on most informative features, creating a clear and interpretable decision structure. Decision trees are employed to create a clear, interpretable model for ransomware detection, providing insights into the decision-making process of the algorithm. The next algorithm is k-nearest neighbor. It is simple, instance-based machine learning algorithm used for both classification and regression tasks. In KNN, an input data point is classified based on the majority class for classification or average for regression of its k-nearest neighbors in the feature space. KNN relies on distance metrics such as Euclidean distance to determine the similarity between data points. It contributes to the diversity of model ensemble, offering a different approach to pattern recognition and aiding in the overall accuracy of ransomware prediction. The next algorithm is support vector machine. It is a supervised machine learning algorithm that aims to find the optimal hyperplane to separate data points in the different classes. SVM is effective in high-dimensional spaces and it can handle linear and non-linear relationships through the use of kernel functions. It identifies support vectors, data points closest to the decision boundary, and maximizes the margin between classes, providing robust classification in various applications. SVM is chosen for its ability to create clear boundaries between normal and ransomware script execution in the feature space, contributing to the accurate classification. As an extension, we have used other deep learning models to improve detection accuracy and for final prediction. Also, we have used Flask and SQLite for user testing and authentication. We have evaluated this project using different error metrics which are accuracy, precision, recall, and F-score. Here we have accuracy comparison graph. Here on x-axis we have accuracy score for each algorithm and on y-axis we have algorithm names. It is a measure of overall correctness of the model and it is calculated as the ratio of correctly predicted instances to the total number of instances in the dataset. It provides a general assessment of the model's performance across all classes. Here we have precision comparison graph. It is a measure of the accuracy of positive predictions made by the model. It assesses the model's ability to correctly identify instances belonging to a specific class, minimizing false positives. Here we have recall comparison graph. It is also known as sensitivity or true positive rate. It evaluates model's ability to capture all instances of a particular class. It measures the proportion of actual positive instances that are correctly identified by the model. This is the F1 score comparison graph. It is the harmonic mean of precision and recall, providing a balanced measure of a model's performance. It is particularly useful when there is an uneven class distribution or when both precision and recall are critical. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the dataset folder. We use this dataset to train the algorithms. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file which contains algorithm information and that will be loaded into the project code during runtime. Here we have IPYNB files. These are the Jupyter Notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the sign-up file. This file is a database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer to execute the project. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. Here we can see that current directory is changed to the code folder's path. Here we need to type the command python space app.py and click on enter. This will compile app.py file and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flash framework will host the application locally at the default address, which is the localhost, and the port unless configured differently. This is the localhost and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying this link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project which is displayed in the browser, and this web page is built by using the Flash framework. Here we can see a register link. First we need to click on it and enter all the sign up details if you are signing up new. I have already signed up and I have an account in it, so we'll directly click on sign in. Here we need to provide our credentials, which are the username and the password, so I am giving my username and the password. And now we need to click on sign in. We have signed in successfully. These are the parameters which are need to be entered. Based on the given parameters, the system will predict whether it is ransomware or not. Now we will understand all these parameters. This is instruction. It is the parameter represents the total number of fundamental operations executed by the processor, providing a high level of overview of computational workload in performance monitoring. Here we have LLC stores, which is last level cache. Its stores refer to the number of stores or write operations that occur in the last level of cache hierarchy. It indicates how often data is written to the cache, providing insights into the memory write patterns. Here we have L1 I cache load misses. L1 instruction cache load misses represents the number of times a requested instruction is not found in the L1 instruction cache. It reflects the efficiency of L1 cache in supplying instructions to the processor. Here we have branch load misses. Branch load misses indicate the number of times a load instruction misses in the branch predictor. This metric is relevant for understanding the efficiency of branch prediction and its impact on program execution. Here we have node load misses. Node load misses refer to the number of cache misses that occur when loading data from the system's memory hierarchy. This metric helps in evaluating how effectively data is retrieved from different cache levels or memory nodes. Here we have REQ, which means read request. It represents the number of requests made by the system to read data from the memory. It reflects the demand for data, read operations within the system. Here we have read bytes. It indicates the total number of bytes read from the memory. This metric provides information about the volume of data read during the specific period. Here we have write requests. It represents the number of requests made by the system to write to the memory. It reflects demand for data write operations within the system. Here we have write bytes. Write bytes indicate the total number of bytes written to the system, which is written to the memory. This metric provides information about the volume of data written during the specific period. Here we have flush operations. Flush operations represent the number of times data is explicitly removed or flushed from a cache. It is relevant for understanding cache management strategies and their impact on system's performance. Here we have read total times. It represents the total time taken for read operations, incorporating factors such as latency and access times. It provides a holistic view of the efficiency of the memory subsystem for read operations. Here we have write total times. It represents the total time taken for write operations, encompassing factors such as latency and access times. It provides a comprehensive measure of the efficiency of the memory subsystem for write operations. Here we have flush total times. It represents the total time taken for flush operations, including factors such as latency and access times. This metric helps assess the efficiency of cache flushing mechanisms in memory hierarchy. Now we will enter all these parameters. So the instructions value is 6990 7324, LLC is 19516, L1 I cache is 80741, branch load is 278752, and the node based misses are 0, read requests are 0, read bytes are 0, write requests are 0, write bytes are 0, flush operations are 0, read total times are 0, write total times are 0, flush total times are also 0. Now we will click on predict. Based on the given parameters, it has predicted as benign. Now we will enter one more parameters and see what will be predicted. So the instructions is 3536715, LLC is 20419, L1 cache is 123211, branch load Mrs. R 95047, node load Mrs. R 95047, read requests are 0, read bytes are 75, write requests are 307200, write bytes are 0, flush operations are 0, read total times are 679, 4522, write total times are 0, flush total times are 0. Now we will click on predict. Based on the given parameters, it has predicted as ransomware. Now we will log out. Conclusion of the project. The project successfully introduces an innovative approach to ransomware detection utilizing virtualization technology, hardware performance counters, and I/O events data to enhance accuracy while minimizing systems performance impact. Through extensive experimentation, the project evaluates various machine learning algorithms including SVM, KNN, decision tree, random forest, XGBoost, DNN, and LSTM, revealing that random forest and XGBoost consistently demonstrate high accuracy in predicting ransomware activities. The project explores the efficacy of deep learning models, specifically DNN and LSTM, contributing valuable insights into their performance in comparison to traditional machine learning algorithms, further enriching the diversity of predictive approaches. The project contributes to the cybersecurity community by publishing a publicly accessible dataset derived from various programs, fostering collaboration and enabling researchers to benchmark their ransomware detection models. The project seamlessly integrates Flask for web framework and SQLite for user registration and authentication, providing a user-friendly interface where user can input data, have it pre-processed, and obtain predictions from the trained model, enhancing practical applicability.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.